All right. This is 3.2 continued. Now we're going to solve by factoring. I had you work on factoring quadratics. We just didn't have it equal to anything, so it was just factoring. Now we got to take it a step further. So I'm going to have you draw your factor box. You put in the first term. We put in the last term. We multiply them together, and we get 36x squared. So I need two things that multiply to that, but add to negative 12. So they add to a negative. So I know it's a negative times negative to get me the positive, and add. And so I got 6x and 6x. 6 times 6 multiplies 36, and they add to negative 12. So I factor out, and I get an x minus 6 minus 6. So this is what we've done before. So this gives you x minus 6 times x minus 6. That's what you did before when you factored, but we have that this is equal to 0. So I need to solve. And that zero product property told you that if two things multiply together and equal 0, one or both need to be 0. So what you do is you set each of these equal to 0. Well, they happen to be the same thing. So it's x minus 6 equals 0. So you don't have to rewrite it like you did down here. You could have done it from here. Oh, well, this has to equal 0. I'm going to solve for x. Oops, that's a 0, sorry. And same thing. This has to equal 0, and I'm going to solve for x. So to solve for x, I add 6. So x equals 6. But every quadratic has two solutions, and these are both 6 in this case. Okay? You have to have two answers. The only time the numbers are the same is when the vertex is on the x-axis. Okay, so for number 8, we need to first get it equal to 0. So I do, especially when factoring, I like leaving my x squared positive. So I'm going to have x squared minus 14x plus 40 equals 0. So I have my first term, I have my last term, multiplies to 40 but adds to a negative. Well, that'd be 10 and 4, so I have 4x, 10x, so I have an x minus 10, x minus 4. And also, when you had this written here, when we were graphing, whenever we had something grouped with x, we did the opposite, or we used the opposite sign. So if you notice, this is minus 6, the answer was a positive 6. So in this case, I have x minus 4. Remember, this equals 0. I'm going to get x equals positive 4. Here I have an x minus 10 equals 0. Add the 10, and you get positive 10. Okay? Excuse me. All right, now, in number 9, I need to get it equal to 0, so I'm going to subtract the x squared and add the 6x. So 2x squared minus x squared just gives me x squared. I have 5x plus 6x, so I get 11x. Oh, and for this problem to work, I'm sorry, we're going to make this a plus 28, the problem, change the actual problem. And then I just have that positive 28 on the end. Okay? So when I factor, draw my box, write in the first term, write in the last term, these multiply together to a positive 28. Now this time they add to a positive, so I know both of these are positive. Okay, because remember, when they multiply to positive, they have to be the same sign, either both negative or both positive. And then you got to figure out what they add up to. Okay, so what number equals 28 but adds to 11? So that would be a 7 and a 4. So I have an x plus 4 and an x plus 7. So in this case, x will equal, and we just do the opposite symbol. So I have a negative 7, negative 4, because that's what happens when you set them equal to 0. And then number 10 is kind of our factoring only backwards. So this says we want the standard equation, which if you notice, these started from standard. That's how we filled in the inside, and we got the factored form on the outside. Well, this gives us that factored form, or x-intercept form, and it wants the standard equation. So I'm actually going to take my box, and I'm going to do the opposite thing. So instead of starting inside and working out, I'm going to start on the outside, x plus 1, x minus 4. You can use these boxes to distribute, and that's what we're doing. So we had this column times this row is what goes in that box. This column times this row would be a 1x, so positive x. This column times this row would be a negative 4x. And then this column times this row would be a negative 4. Okay? And just like with these up here, these diagonals, they add up to that center number. We had our first and last term, and the diagonals added up to the center number. So here, I know I'm going to have, well, this is y equals. I know my first term is x squared. And then I have a negative 4x and a positive x. That's going to add to a negative 3x. And then my last number is the negative 4. Okay? That's the same thing if you were to do this by distributing. You would take this first term times everything in the second parentheses, and you take this last term and you multiply it times everything in the parentheses, and then you combine like terms. This box does all of that. Okay? And when we get to multiplying and distributing bigger things, the box helps keep it very organized. The diagonals are always the like terms. All right, so now for 11, a skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Use this formula that it gives, h equals negative 16t squared plus h naught, to write an equation that gives the skydiver's height, which is h, in feet during a free fall with t seconds after the skydiver drops out of this airplane. So h is the height, and it's going to start, h naught means the initial height. So the equation is going to look like this. It's going to keep that the same, but our initial height is 4,624. Okay? Now we want to know, is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? So we could do a couple of things here. Well, we could find out when they hit the ground, and if 18 is after that or before that, we would know if it's safe or not. Or we could take 18 and plug it in for time. And so if we do that mathematically here, we're going to negative 16 times 18 squared plus 4,624. And you are going to get that h is a negative 560. So 0 would be the ground. You started at a positive, the ground is 0, but we're at a negative. I would say do not wait 18 seconds to open the parachute. So is it possible for that skydiver to wait that long? No, it's not. You might want to put like something like it would already hit the ground, that kind of thing. And I'm going to take this one step further. So we answered that question. You just need to give it a reason. I want to take it one step further and say, okay, well, when would they hit the ground? So we know the time frame they would actually need to pull the cord. Well, that would make h 0. The height would be 0 because that's the ground. So if I make 0 equals negative 16t squared plus 4,624, I can actually calculate the time it takes to just hit the ground without the parachute. Okay? So I'm going to solve. I'm going to subtract the 4,624, and now it equals 16t squared. To get t squared by itself, I'm going to divide by negative 16. Okay, so I get 289 equals t squared, and you square root both sides. Now, when you square root both sides, you're going to get t equals a positive and negative 17. Well, we're not wanting negative time, so in this case we are just, in this case we just want the 17, okay? It's going to take 17 seconds to hit the ground without opening a parachute.